Hi, it's Mr. Bennett. In this video, what we're going to talk about is we're going to talk about seafloor spreading. Now, the reason why we're going to talk about seafloor spreading is let's go back to our previous video. And we talked about Wegener, and Wegener was the first guy to come up with a serious hypothesis about continental drift and the continents were moving. Well, here's the thing. When he first came out with the idea, he was laughed at. He was rejected. Nobody bought his idea. Now, even though he was able to show them all the evidence that the continents were all together at one piece, no one believed him because he had no way to explain how the continents were moving. He could show all this wonderful evidence that said, hey, the continents are moving, and at one point they were all together and they've moved apart, but he had no way of illustrating how this happened. He had no way to describing how these huge masses of land were moving. And so because of that, Wegener's ideas were completely rejected out of hand, especially in the United States. We laughed at him pretty hard. Now, Wegener died in 1930 in Greenland. He was doing a weather expedition there and got caught out in the wind weather and died there. And so Wegener never lived to see his ideas validated because it would take another 30 years before we'd finally come up with a way of showing how the continents were actually moving. Now, the reason why Wegener wasn't able to come up with a way of showing how the continents were moving is because the best evidence for plate tectonics is actually found on the ocean floor. What you're looking at here, this is actually two plates separating. Over here you got the North American plate, and over here you got the Eurasian plate. And these plates are separating from each other. Okay, the North American plate is going this way, the Eurasian plate is going that way, and the scuba diver right here is right in between the two plates as they're separating from each other. This is something you can really only see underwater. And so the best evidence for plate tectonics is found on the ocean floor. Well, at the time Wegener was alive, we knew basically nothing about what the ocean floor looked like. We had some ideas, and the best idea at the time was that the ocean floor was just basically a big old thing of sand, that all the sediments from the rivers had settled down there, and so basically what the ocean floor looked like is it looked like the Sahara Desert, but underwater, and that's what we thought. So because the best evidence for plate tectonics is found on the ocean floor, and we had almost no ability to explore the ocean floor in the 30s and the 40s, Wegener wasn't able to find his evidence that showed that continental drift is actually a real thing. Okay, to show that plate tectonics actually happens and continental drift actually happens, it would actually take a war for us to find out that this was going on. And World War II would play a key role in confirming the role of plate tectonics and continental drift. Here's what you got going on. During World War II, the Nazis, we'll go ahead and put a little swastika right there, in Germany, were fighting the United States and the Soviet Union and Britain and so forth. And the Nazis knew that if America could get all of our tanks and aircraft and ship across the Atlantic Ocean, that they could win the war. And so what the Nazis did is they built a whole bunch of these things right here, which are called U-boats. Now, U-boat is the German way of saying submarine because the U stands for Unterseeboot, all right? Now, these German U-boats went nuts in the Atlantic Ocean, and they sank almost 3,000 American ships. Each one of these dots you see right there is an American ship that was sunk by the German U-boats. And we almost lost the war because of this, because the German submarines were doing such a good job of sinking all of our ships. Well, thankfully, the British found a way to get around this, and what happened is the British invented sonar. And they invented sonar to find the German U-boats so we could find them, sink them, and then that way we could win the war instead. Now, how sonar works is if you have a ship that's got sonar, it sends out sound waves, okay? Sends out these sound waves. These sound waves go and hit things and bounce off of them, and then you listen for the echo. Now, sonar can be used for a couple of things. Number one, sonar can be used to show you where the bottom of the ocean is, because when those sound waves hit the bottom of the ocean, they bounce off, you listen for the return, and based on how long it takes you to get the echo, you know how far away, how deep down the bottom of the ocean is. It also works for finding a submarine. And so the British invented sonar, and this was used to help hunt down these German U-boats. And so every British and U.S. ship had sonar on. We put sonar on every U.S. and British ship during the war. We're able to use this to find the U-boats, sink them, send them to the bottom of the ocean, and win the war. But the other thing that sonar did is for the first time ever, humans were able to get an idea of what was at the bottom of the ocean by using sonar. Sonar allowed us to see, if you will, what's going on at the bottom of the ocean. And this is something we've never been able to do before. And if it wouldn't have been for World War II and needing to sink submarines so we could win the war, and that's the reason why we invented sonar, we wouldn't have found out what's at the bottom of the ocean so quickly. All right, so the British invented sonar. The British and the Americans, we put sonar on all of our ships during World War II. And so we have all these ships going out throughout the oceans using their sonar, and that's starting to tell us what the bottom of the ocean looks like. Well, let's bring in our next character, Harry Hess. And this is going to be the guy who's going to make the key to discovery that is going to lead to the proving of Wegener's theory of continental drift. Here's a little bit about Harry Hess. Here you can see him here teaching at Rutgers University about plate tectonics and all that good stuff. So what did Harry Hess do? Well, he was a geologist, which means he studied the Earth, and he joined the Navy in World War II, and he was given command of a ship. There's a ship right there called the USS Cape Johnson. So during World War II, he commanded this ship, and he was in the Pacific Ocean, sending, ferrying troops back and forth between the United States and where they were fighting. Well, because he was a geologist, the whole time his ship was going, he constantly used his sonar, and he used that to map what the bottom of the ocean looked like. So the whole time his ship was moving, he was using his sonar to map the bottom of the ocean, find out how deep down things were. And he did this during the entire time he served during World War II. Well, here's what he discovered while he was using his sonar to map the bottom of the ocean. He found out that the bottom of the ocean is not a bunch of sand dunes. He found a whole bunch of mountains, and he found canyons, and he found trenches at the bottom of the ocean. This is what the bottom of the ocean looks like. And these things here are huge mountain ranges that are found at the bottom of the ocean. And Harry Hess was the first one to find them using the sonar on his ship. Okay, so that's going to be the key thing that Harry Hess found, is he found that there are mountains at the bottom of the ocean, and there are trenches and so forth. And so the ocean is not just some flat bottom, it's got big mountains, big trenches, and so forth going on there. So that was Harry Hess's key contribution to understand the process of plate tectonics, is he was able to find that first evidence of plate tectonics by using his sonar to figure out what's at the bottom of the ocean. Okay, so Harry Hess was the first one to do a detailed mapping of what the bottom of the ocean looked like, specifically the Pacific Ocean. Fast forward a few years from Harry Hess in World War II, and in 1960s, geologists, Harry Hess was part of the team that helped do this, made another discovery. And the discovery that they found at the ocean floor is not all the same age. That there are parts of the ocean floor that are younger, and there are parts of the ocean floor that are older. So, to understand what's going on here, first off, let's make a definition of a term. First off, the term mid-ocean ridge, okay? This is a mid-ocean ridge, this is a mid-ocean ridge, this is a mid-ocean ridge. These are these ridges found in the middle of the ocean that are these huge mountain ranges that are found on the bottom of the ocean floor. And this is a place where two plates are pulling apart from each other. So the mid-ocean ridge are these underwater mountain ranges that you find in the ocean. Now, here's the key discovery that they found in the 1960s. They found that the closer you get to a mid-ocean ridge, the younger the rock is. And the further away from that mid-ocean ridge you are, the older the rock is. And so in this picture here, the red rock is the very young rock. And if you look at it, all the very, very young rock is right here next to the mid-Atlantic ridge, right? That's that underwater mountain range found in the Atlantic Ocean. You can see the same thing going on here in the Pacific, and you can see the same thing going on over here in the Indian Ocean. That wherever you are close to one of these mid-ocean ridges, the rock is very, very, very young. The further away you get from one of these ridges, like here off the coast of the eastern United States, you can see the rock is very, very old. And so that's a discovery that we made in the 60s, that we found that the ocean floor is not all the same age, and actually the closer you get to these mid-ocean ridges, the younger the rock is. The further away you get from it in either direction, the older the rock is. Here you can see off the coast of Africa, the rock is very, very old as well. Now, why is it that we have very young rock close to the ridges and very old rock very far away from the ridges? That's because of seafloor spreading. This was the definitive proof that plate tectonics is happening and that seafloor spreading is going on. And what seafloor spreading is it's that ridge push that we talked about in our last video. That at these mid-ocean ridges, magma is forced up through the surface of the Earth. When that magma is forced up through the surface of the Earth, it cools and becomes new crust. As it becomes new crust, it pushes the existing crust out of the way. So here at this mid-Atlantic ridge, what you got going on is magma is leaking up along the center of it. And as it does that, it cools, hardens, and pushes the existing plates away from each other. This is the reason why the North American continent is going this way, is because here at the mid-Atlantic ridge, it's getting pushed away, and it's heading slowly to the west. It's also the same reason why Europe and Asia are going this way, is because the plate that they sit on is getting pushed that way by what's going on with the seafloor spreading at the bottom of the Atlantic Ocean. Okay, once again, this little animation down here shows you what's going on. That the magma comes up, it cools, it makes new crust. That new crust pushes the existing crust out of the way, and this is what we call seafloor spreading. So at the bottom of the ocean, at these mid-ocean ridges, what's going on is the bottom of the ocean is actually getting bigger, and it's getting bigger because of ridge pushes during seafloor spreading. All right, once seafloor spreading was discovered, we finally had a mechanism to explain how the continents were moved, and that was the evidence that showed that Wegener was right all along. The evidence of seafloor spreading was what we needed to show that Wegener was right all along and that the continents are actually moving. Because at these mid-ocean ridges, new crust is being formed as the magma leaks up from the bottom. As the magma leaks up from the bottom, that's going to push the existing crust away from each other, and that's the evidence that we needed to show that continental drift is actually happening. Because here, at the mid-ocean ridges, the North American plate is being pushed away, and the Eurasian plate are being pushed away from each other because of seafloor spreading. So finally, 30 years after his death, Wegener was shown to be right in the 1960s when we discovered seafloor spreading, and that he was right all along. Now, one thing I did not talk about too much in this video, and this will be the thing that we talk about in our next video, is I talked about we know the age of the bottom of the ocean. But I did not tell you how we know the bottom of the age, because that is a key thing you need to understand that shows that seafloor spreading is happening. So in the next video, we'll talk about real briefly how we're able to figure out how old the rock is at the bottom of the ocean. And that's something that's called paleomagnetism. Okay, so that wraps up that video on seafloor spreading. Hopefully you're able to describe the process.